Hello all and welcome to the video lecture on register indirect addressing mode. In my last videos I have already explained about the immediate addressing, then register addressing mode and direct addressing mode. So now today we will discuss what is register indirect addressing mode. Now in case of an register indirect addressing mode, a register is used as a pointer to the data. That means your data is now not directly in the instruction and also not it is given into any register whose name is mentioned in the instruction. But now here you are going to mention the name of the register into the instruction, but that register is now used as a pointer to the data. So the meaning is that this register that will now contain the address of the memory location where your data is stored or placed. Now remember one more thing, that in case of an register indirect addressing mode, only two registers you can use, that is R0 and R1 register. So R2 to R7 registers, they cannot be used to hold any address of your RAM location in register indirect addressing mode. Now we will discuss the different examples, and one more important point here is whenever you write in the name of the register in the instruction, then it should be preceded by one sign which is @ sign. Okay, so now we'll discuss one example. Suppose we write the instruction move a comma @R0. So now what is the meaning of this instruction? So the meaning is your R0 here will act as a pointer to the data. That means this R0 will contain the address of RAM memory location where your data is stored. So R0 may contain your address, and to that address your data is stored. So that is represented by this @R0, and this data will be then moved or copied to the accumulator. So here why it is called as an indirect addressing mode, because your data is not directly inside your register, but that data is present inside the address, and that address is basically present in the register which you are going to mention in your instruction. That is what is the meaning of the instruction move a comma @R0. Another example you can write it at move @R1 comma B. So what is the meaning of this? The meaning of this is move the content of this register B into the RAM location whose address is held by R1. So again here your R1 contains the address, and in that address you are going to copy or move the data from this register. So this is what is a register indirect addressing mode. Now I will explain you why this register indirect addressing mode is useful with the help of one example. Now suppose you consider one simple program where you want to store some data value. Let us say that data value is 55H into some consecutive RAM memory locations. Okay, and that RAM memory locations are say from 41H or say 40H to 45H. These are the consecutive RAM locations. Okay. Now if I write this same program using the direct addressing mode, okay, which we have discussed in my last video, then in that case I have to write the code like this. So first I have to load my data bit into the accumulator, okay, and then I have to move this data byte from accumulator to all these memory locations, that is 40H comma A. Then move 41H comma A, move 42H comma A, and so on up to 45H, right? So this is my direct addressing mode, but here if you can see, if my consecutive memory locations are more, then you have to repeat this instruction, that means write these instructions again and again, because the memory locations are different with direct addressing mode. But with the help of indirect addressing mode, you can basically reduce this code by using some special instructions. So now I will write the same code by using a register indirect addressing mode. Okay, now here we can use the loop structure to reduce this length of the code if we use register indirect addressing mode. So first I will write the simple code and then we'll convert it by using some loops. So my first instruction in this is say move a comma hash 55h. So I have transferred my 55h data into the accumulator. Now I have to use a register R0. So I will load R0 is equal to hash 40h. So now my R0 is pointing to the RAM memory location 40h by this instruction. Okay. Then I will write the next instruction, that is move at the rate R0 comma A. So now what will happen because of this? Whatever is present in my accumulator, so my accumulator is containing 55h, that will be copied to the memory location whose address is present in R0. And what my R0 contains? My R0 contains the address 40h. So now by this instruction, my data 55h will be copied to the memory location 40h. Okay. Then what I have to do? After this, I have to increment this R0 and again I have to write the same instruction, that is move at the rate R0 comma A. By incrementing R0, now my R0 is initially 40. When you increment it, now my R0 will become 41. And then again you copy the content of accumulator into the memory location 41h by writing the instruction move at the rate R0 comma A. And these instructions you have to repeat unless and until you get the memory location 45h. So again when you increment R0, now my R0 will become 42. Okay, so again you write the same instruction move R0 comma A, you again increment it. Now my R0 is pointing to 43, so again I will write now move at the rate R0 comma A and again increment R0. Now it will become 44. Again you move this at the rate R0 comma A and again you increment and then you will get 45. So I have to write this code, but here also if you see these instructions I am repeating again and again. Okay, so now I can reduce this program by using loops if I use a register indirect addressing mode. So now how I can reduce? So now in this case I can use one counter for keeping the track of these memory locations. So my first instruction is move a comma 55h, then move R0 comma hash 40h. So now again R0 is pointing to the memory location 40h and accumulator contains my data 55h, which I am going to load into these successive memory locations. Now what I will do is, now I will take one counter to keep the track of this memory location, and for that I am using one register R2. Why I am taking the counter is equal to 5 because I want to store it into the consecutive 5 memory locations. Okay, so whatever are the memory locations, you take that counter. Now after that my next instruction will be now move at the rate R0 comma A. Then you simply increment R0 and use the instruction DJNZ R2 and use some label, and I am transferring that label control over here. Now what will happen with this code? First my accumulator will be loaded with my data. My R0 register is pointing to the first memory location, that is 40h. Then I have taken one counter that is R2 is equal to 05, which will keep the track of my memory locations from 40 to 45h. Now I am transferring my accumulator content to the at the rate R0 means R0 is 48. So by this instruction I am moving my accumulator data, that is 55, to this memory location 48. Then I have incremented my R0. Now R0 will become 41. And here I have used one instruction DJNZ. DJNZ means decrement and jump if not 0. So you have to check for this R2 register by decrementing it by 1. So you decrement it by 1. So R2 will now become 04. It will check whether it is 0 or not. If it is not 0, then that it will transfer the control to this label, that is up. So if it is not 0 and it is already incremented, so now it is pointing to 41h. So my data will be copied from accumulator to that particular memory location. So instead of writing such a big code, what I can do is I can reduce my code by using the loops. I can use the loops if I use a register indirect addressing mode, but that is not possible with the direct addressing mode. So this is what is one of the advantage to go for an register indirect addressing mode. So if you find @ sign, then it indicates that your register, whatever R0 or R1 register, whatever you are going to mention in the instruction, will contain the address of the memory location where your data is stored in register indirect mode. So this is what all about register indirect mode. So if you like my video, then please share the video with your friends, and if you have not subscribed to my channel, then please subscribe to my channel.